All right, let's jump right in. We're going to tackle a huge question today. How do the world's biggest ships, these massive floating cities, see when it's pitch black? I mean, completely dark. Well, the answer is this incredible technology that gives them a kind of superpower, a way to see when their own eyes are totally useless.
Seriously, how is that even possible? I want you to picture this, a container ship, 1,000 feet long, that's more than 3 football fields end to end. Now imagine it's wrapped in a fog so dense you literally can't see the front of your own ship. And yet it just keeps on moving, totally confident. The secret? It's not about sight, it's about a completely different and way more powerful kind of vision.
And you know what? It all boils down to a super simple idea. An echo. Yeah, that's it. But we're not talking about yelling into a canyon and waiting for the sound to come back. No. These ships send out an invisible pulse of energy, and then they just wait and listen for it to come back.
And that system, well, it has a name you've definitely heard before. Radar. It's actually an acronym. Stands for Radio Detection and Ranging. When you get right down to it, it's a machine built to do 3 basic things. 1, detect an object. 2, figure out exactly how far away it is. And 3, pinpoint its direction.
Okay, so how does it actually measure that distance? The whole process is actually pretty straightforward. First, the radar blasts out a super short pulse of microwave energy. That pulse shoots out at the speed of light, hits something, could be another ship, a buoy, maybe the coastline, and then a tiny bit of that energy bounces back. That's the echo. The system's job is to time that round trip, down to the nanosecond. And since we know the speed of light, doing the math to get the distance is, well, simple and incredibly accurate.
But, just seeing a blip on a screen isn't enough, right? For a ship to navigate safely, that picture needs to be sharp. It needs great resolution, kind of like the difference between an old standard def TV and a brand new 4K screen. So let's dive into how radar actually gets that crystal clear picture.
So, when we talk about radar clarity, we're really talking about 2 different things. First up, you've got range resolution. Think of this as being able to tell 2 targets apart when one is directly behind the other. The key to this is the pulse length. The shorter and sharper the pulse, the better you can separate those 2 objects. Then you have bearing resolution. This one is all about telling 2 targets apart when they're right next to each other, side by side. And that all comes down to how narrow the radar beam is. A really tight focused beam is going to paint a way more detailed picture.
Okay, so we've got this incredible machine that can paint this detailed picture of the world. But here's the catch. The ocean is a really noisy place. The raw information coming into the radar, it's not clean, it's messy. And this is where the human element, the skill of the operator, becomes absolutely crucial.
I'm not kidding. On a bad day, that radar screen can look like total chaos, just a mess of static. You get what they call clutter from waves bouncing the signal all over the place. You get more clutter from heavy rain or snow. And then there's something even trickier, ghosts. These are false echoes that look completely real, but there's nothing actually there. The navigator's job is to somehow cut through all that noise and find what's real. And how do they do that? Well, they've got some pretty powerful controls to work with. The main one is gain. You can think of it like a volume knob. It adjusts the sensitivity. If you set it too low, you're going to miss small but important targets, but if you crank it too high, the whole screen just fills up with noise. Then you've got these amazing filters. ACA, Anti-Clutter C, that helps tune out all the mess from nearby waves. And AC Rain does the exact same thing for bad weather. It is a constant, delicate balancing act to get it just right.
Yeah, those false echoes can be a real headache. Here's a classic example. A radar pulse can get trapped, bouncing back and forth between your ship and another big ship that's close by. What you see on the screen is a whole line of ghost targets that look like they're marching away from you. This is where experience is everything. A seasoned operator just learns to recognize these phantoms for what they are and ignore them.
You have to remember, for decades, operators did all of this by hand. I'm talking a grease pencil and a plastic plotting tool, manually tracking every single blip on the screen to see if they were going to collide. It was incredibly intense, high-stakes work. But then came a technological revolution, something that basically gave the navigator a brilliant, tireless co-pilot. And that co-pilot is called ARPA. It stands for Automatic Radar Plotting Aid. ARPA is basically a brain that plugs into the radar. It does all that manual work automatically. It doesn't just show you a blip, it latches onto that blip, tracks it, calculates its exact course and speed, and, this is the most important part, it predicts where that target is going to be in the next few minutes and screams at you if there's a risk of collision.
ARPA has its own visual language, and it's designed to be super clear. So when it first picks up a target, you'll see a little broken square. That means it's still figuring things out. After a minute or so, that turns into a solid circle with a line sticking out of it. That line is its vector, showing you where it's headed. Now, if that vector points to a collision course, damn! A flashing triangle appears and an alarm goes off. You can't miss it. And if for some reason the system loses track of the target, you'll see a flashing diamond. It's like an instant summary of what every single ship around you is doing.
Now, the most important part to understand are those lines, the vectors. ARPA can show them to you in two different ways. On one hand, you have relative vectors. This is the big one. It shows you how that other ship is moving relative to you. It answers the question, is that thing going to hit me? If you see a vector pointing straight at the center of your screen, that's bad news. That means collision. Then, on the other hand, you have true vectors. This just shows you what every ship is actually doing, its real course and speed over the water. It's great for getting the big picture of the whole traffic situation.
Look, avoiding collisions is obviously the most dramatic and important job for radar, but its power goes way, way beyond just that. You should really think of it as the ultimate multi-tool for a modern navigator. It's used for a ton of other essential jobs on the bridge.
I mean, it's not just about spotting other ships. Navigators use it to pinpoint their own position by taking ranges off of lighthouses or capes on the coast. When they're in a super tight channel and can't see a thing, radar allows them to pilot the ship with pinpoint precision. Oh, and it's also a fantastic weather detector. It can spot heavy rain and thunderstorms miles and miles away, giving the ship plenty of time to go around. But there's this one technique that is just so clever, it's called parallel indexing. Here's how it works. The navigator draws a line on the radar screen that's parallel to the course they want to follow. They set it up so that line passes right through a fixed object, like a buoy. Then, as the ship moves forward, the little echo from that buoy should just slide perfectly down that line, like it's on a rail. If that echo starts to drift off the line, they know instantly that wind or current is pushing them sideways. It's just a simple, brilliant trick to make sure you're staying exactly where you want to be.
So, all of this brings us to a really important final question. We live in the age of GPS, right? Satellites can tell a ship its position anywhere on Earth down to a matter of feet. It's incredibly accurate. So, you have to ask, with that kind of tech in our pocket, why on earth are we still using this 80-year-old idea of just bouncing radio waves off stuff?
And the answer is simple, but it's so important. GPS tells you where you are. It's all about you. But GPS has no idea about the small fishing boat with its transponder turned off. It doesn't see the buoy that's lost its light. It doesn't know about the squall line building up just over the horizon. Radar tells you what's actually out there with you, in the real world right now. And that's why it is still the one indispensable eye that lets a ship truly see in the dark.